So waves are relatively well observed, and the way that's done is something called a wave rider buoy. And so there's an example of one in the picture here. So there's one deployed, in fact, just off the coast of Bateman's Bay, and you can see that here. So it's just a little bit to the north of Bateman's Bay, outside the heads. And often these observations of waves get represented in terms of a directional spectrum. So if you follow this link here, you'll find lots of these spectra for different times and for different locations up the New South Wales coast where they have these wave rider buoys. If we look at these sort of spectrums, they tell you quite a lot of information here. So the fact that it's a spectrum it's showing you the amount of wave energy at a given frequency, or in this case at a given period, which are these numbers in seconds. So 5 seconds is this line, 10 is this, 15 is this circle, and so on. And it's telling you how much energy is at those periods, but also how much energy is in a given direction. So 0 degrees being north, 180 being south. This is telling you that most of the wave energy is in this, for this buoy here, is coming from the southeast. Okay, so it's coming in, on average at this time, it's coming in from this direction here. You'll see at the top here, it's also telling you what the significant wave height is. So that's this HS, and what the average period is, and what the average direction is. So 154, 10 seconds. So that's this line here, and a significant wave height of 1.8 meters. So this sort of spectrum that you see here, where the energy is quite concentrated in a particular direction, and it's concentrated at a longer wavelength, at a longer period, and also a longer wavelength, a longer period of about 10 seconds. This is characteristic of a swell seed propagating in. For comparison, if we take a different spectrum from a different time for the buoy that sits off Sydney, you'll see you've got this very dispersed spectrum. So there is wave energy coming over essentially a full 180 degrees or more, with no real obvious peaks in that spectrum, and also with quite a lot of energy at much higher frequencies, so much shorter periods and shorter wavelengths. And so this sort of spectrum is characteristic of that wind sea condition, where you've got waves generated actively by wind kind of propagating in all directions, and you don't have this coherent remotely generated swell. So you can infer a lot of information from these directional spectra.